Hello, welcome to lesson 10. And this lesson will be widely concentrating on using logical and reference functions. So I'll be talking a bit about the if function, choose, and, or, XOR, and basically everything that you could do with decision-making functions. This lesson is brought to you by the American Institute of Techniques and Management. So, let's begin lesson 10. So, as for the previous three parts regarding formulas, we'll be talking about the insert function and basically inserting the function. But first off, let's save this so we don't lose this lesson for later on. So we want it to be lesson 10. Great. So decisions. So if one student gets 88% on a test, is that a B plus or is it an A? Or if you have 5 or 6 degrees, is it a 5 or is it a 6? If your company's new product earns at least $15 million in revenue, how much of a bonus should you give to the team? Or do you have to get 20 million before you do that? How does this affect the financial statements? Well, Excel cannot make decisions for you, but it can help you make better decisions. Using functions such as if and choose, you can set up your worksheet to chart a course through the possibilities. Hey, things could be worse. Wherein, not for Excel, you might have to try the old OJA board technique. Excel also can help you find what you're looking for. Looking for something in a large, complex worksheet can seem like the old needle in a haystack routine. It's okay to admit it. After all, it happens to the best of us. I'm here to help. I will show you a slew of functions that make it easy to look up information that's spread around the rows and columns. So let's begin with testing on one condition. The if function is like the Swiss Army knife for Excel functions. Really, it is used in many situations. Often you can use it when other functions, which I do often in this chapter. If structurally is easy to understand, the function takes 3 arguments. First one, a test that gives a true or false answer. For example, the test. Is the value in cell A1 equal to the value in cell B1? So we have 1 and we have 2. So the answer would be no. This can have only one of 2 possible answers, yes or no. In computer talk, that's true or false. This is not a calculation, mind you, but a comparison. So the second argument it can take is the data, and it has to take the data to be returned by the if function if the test is true. And the third argument, the data to be returned if the if function releases false. Well, it sounds easy enough, so let's basically just use it. So let's use the function over here. Let's write it. That is the if function. And please try to be focused because this is probably the most important function of all. If you ever done any programming, then this function should be really, you should really know it very well. If argument is used probably in all programming languages, and this is the most basic programming thing you can actually do, and it is widely used in functions. It is very useful and it really helps you. So first off, let's do the equals if. Great. So the logical test. Let's begin with A1 bigger than A2. Okay. Now we move to the value if true. So let's insert that we wanted to show the value of A2, and if it's false, we wanted to show B2. And let's look it up. It shows 0, but let's put in 1, and let's put in 2 here. So you see the function actually showing us the value. So if the value in the cell, just to show you, in the cell A1 is greater than the value in cell B1, then the value is 2. If we would face the opposite situation, then the value would be 1. But basically, we can also use the actual function bars to be shown. So it didn't really have to be A2; it could be A1. And over here, it didn't really have to be B1. It could be B2. It could be B1. So we would have the very exact same. So let's go 3 over here, and you see it changing. And let's go 4 over here, and again you see it changing. This is basically how it works and how if functions work. But let's say we want text in here. We want it to tell us some good news, bad news, maybe. I guess that would be great. So if A1 is bigger than B1, let's say that would be good news. So to write that down, we just have to put in this sign and write in good news, exclamation mark. Great. And if it would be if we've seen the opposite situation, let's write in bad news. And an exclamation mark. So that was really easy. So see, now you have a simple program, right, telling you that if something happens between these numbers, you have either good news or bad news. This is a nifty little trick. It's, well, if you're a basic Excel user and your boss sees that you can actually use a function like that, well, wouldn't it be really something to show off with knowledge of functions on this level? Okay, but well, we don't really want anything, the function to tell us anything. We want to only hear good news, let's say. So we want this cell to be empty at the moment if it's bad news. So let's just delete this, leave a space, and press enter. See? So if it's good news, great, but if it's bad news, so this is how it works. Basically, this is how awesome Excel sometimes can really be. If therefore, lets you set up 2 results to return. One for when the test is true and another when the test is false. Each result can be a number, some text, a function or a formula, or even blank. So, as seen in the previous example, a common use of if is to see how two values compare to each other and return either one value or the other, depending on how you set up the test in the first argument. If is often used as a validation check to avoid errors. For example, suppose you have a financial worksheet that uses a variable percentage in its calculations. The user must enter this percentage each day, but it must never be greater than 10%. To avoid the chance of errors, you could use the if function to display an error message in the adjacent cell if you mistakenly enter a value outside of the permitted range. Assuming the percentage is entered in cell, let's say D2, here's the required if function. So equals if open D2 and bigger than and you have to use this one, dot one. Oh, dash one. Great. So we input the error. %. In D2, D2 is too large. In other situations, do nothing. So while using functions like this, please note that each sign has a each sign has a very important job to do. Except the text inside the exclamation marks, which is really anything you wanted. But if you miss any exclamation part, anything at all, the function will input an error. So if you, let's say, delete the exclamation marks over here and push enter, it will show the 0 number. If you don't want the 0 number, you have to put in the exclamation marks. So this tests if anything in this bar is bigger or smaller than 1%. So to do it, let's write it 1. So error in D2 is too large. So if we change this bar to percentage, and we have right now written in because 0.5%, I'll allow you to see, and after after 0, you can see it being 0.5. Let's change it to 1. Nothing happens. But if we do 1.5, yeah, we have an error. So another explanation for this function, and I guess something really fun to work with. Let's go to the help of this function, because I believe Excel has a great yeah, a bit lower. Oh yeah, here's the example. Example 2. So we have the actual expenses and predicated expense. So it's $1,500, $500, $900, and etc. So the description for these functions: check whether the actual expenses in row 2, so that would be here, row 2 are greater than predicted expenses, returns over budget because the result of the test is true. So if A2, so A2 is larger than B2, over budget, else okay. So if false, so it's the exact same function but with a different result. So over here we can see it being 900 and 500 over here, so basically the same one but with the row below. So it says okay, it's not over budget, and this is a very good example. A different example could be if you had actual number of stock on in your shop, and you had a lot of stuff on shelves, and here you have the predicted sale for the month, and it could tell you whether you have to order new inventory for your shop or not. Okay, that's it for the if function. And what I want you to do is create your own one. Actually, create at least 3 functions, at least 3 if functions for yourself. So this is the place where you can do it. Write in the description. So what it does, what it's supposed to do, so we can see that you understand how this function works. Okay. So here is your space to enter your function, and here is the area where you can input some data, and from this data create a if function for at least three different variations. So I want 3 different if functions in here. I know we spent a lot of time on this function, but I really deeply believe that this is the most important function in Excel. So the if function can do a whole lot more. A nested function, and what I mean by nested is if you input a if function into a different function, so or input any other functions in an if function, it gives you a lot of more flexibility in performing tests on your worksheet data. A bit of perspective is necessary to get through this. Nested means that you can place basically an if function inside another if function. That is, the inner if is placed where the true or false argument in the other if goes. Why would you do this? Well, the other night we were deciding where to go for dinner. We were considering Italian and decided that if we went to an Italian place and it served manicotti, then we would have manicotti. Otherwise, we decided to just eat pizza. So, logically, this decision would look like this. If the restaurant is Italian, then if the restaurant serves manicotti, then we will have manicotti, else we will have pizza. So this is basically a function like this. I'll write it down for you. I do not insert any data, so it will be wrong, but if restaurant equals Italian, this is the logical test. If true, then we enter if again restaurant serves manicotti, and now we enter if true manicotti. If false, in the nested function, if false, we go and eat pizza. And there is no other option here for this type of. We have no false for this logical view, so we just do this. This will go wrong because we do not have a restaurant or Italian here, so this is just a logical one. So basically this function works only for just to explain to you how it works. So again, if we go to a restaurant which is Italian, then what happens? If the restaurant serves manicotti, then we eat manicotti. Otherwise, if they don't serve manicotti, we eat pizza. And we don't consider going to any other restaurants. Okay, great. See, a error. Okay, great. So you can set up to 64 if statements, although things are likely to get very complicated once you go beyond 4 or 5. I don't think I ever used the fifth if argument. So you can apply a nested if statement to increase the sophistication of the inventory worksheets that I told you about earlier. That has an additional column or a extra item. A hot item can take, well, 3 forms. If the inventory level is half or less or of the recorded level at the last sale date within the last 30 days, then this is a hot item. The point of view is that in 30 days or less, the stock sold down to half of or less than the recorded level. This means the inventory is turning over at a fast pace. If the inventory level is half or less of the reorder level and the last sale date is within the last 31 to 60 days, then this is a warm item. The point of view is that in 31 to 60 days the stock sold down to half or less than the reorder level. This means the inventory is turning over at a medium pace. If neither of the predicting two conditions is met, the item is not assigned any special status. There are hot items and there are warm items. They both must meet the common criteria for the inventory in 50% or less of the reorder level. And this is just another way we can use the nested if functions. This is, as I said, rather sophisticated and rather complicated, so we won't go into it because we won't have enough time to talk about other types of functions. But I encourage you deeply to try out the nested if functions. Maybe one short example equals if, let's say, if this one is smaller than this one, if let's use if again, and another logical description. So here we will use if this one equals this one, then we'll use the true value as good and the false value as bad. Okay, and we now lock in the nested if function. And what if the entire thing is not true? Then we give out just plain old false. Okay, and we log this function. So there's an error. Let's see where it is. D5 smaller than 6 if E5 equals if it's good, otherwise it's bad, or false. Do you want to accept this correction? We found typo. Yeah, accept it. Okay, so right now it's bad, but let's write in 5, 6. So what happens here? So what happens here is if the D5, which it is this one, so 5, is smaller than D6, then we begin, it's true, so we jump into the nested function, and if these two are equal, which we have over here, if E5 and E6 are equal, it signs in the good one, but if they weren't, let's write in 2, it will write in bad. Okay, but what if we have the opposite situation over here? We have a 7 up here, it will tell us false, it will ignore the nested function here just because this is only for the value if true, and over here we have the value of false, so basically it's false. Okay, so that's it for the if function.